Welcome to Spring LIB.
Hi there. This question is asking us to identify, the hydrogen bond here. And hydrogen bonds are intermolecular attractions. So hydrogen bond is an intermolecular force, which means a force between molecules holding them together. And a hydrogen bond occurs between two polar molecules. I was going to say dipoles, but let's say polar molecules. Two polar molecules that have N to H, F to H, or O to H bonds. So they need to be polar so that there's a positive end and a negative end to the molecule. And they need to have one of these types of bonds so that the neighboring molecules can move close to each other. Since hydrogen is such a small atom, this allows the two molecules to move very close to each other. And just like when you move two magnets closer to each other, you have a stronger force of attraction. All right, so let's look at our options here. The first one has H2O, and we know H2O is definitely polar because it's bent, and it has O to H bonds, so it can participate in hydrogen bonding. However, we're trying to hydrogen bond this to a nonpolar molecule. Methane is a nonpolar molecule, so we will not have a hydrogen bond between these two. All right, let's look at the next one. The next one is H3N. Usually it's written as NH3, but NH3, which is polar because the nitrogen has a lone pair, so this is asymmetrical, and we see an N to H bond there. And then between that and a water molecule. I'm going to kind of sketch it this way. We already talked about that being polar. So yes, we can form a hydrogen bond there. So our correct answer appears to be the H3N, hydrogen bonded to the HOH, the water. But let's check our next two options just to make sure we have the correct answer here and that there's only one correct answer. The next one, well, essentially we see CH4 again. They wrote it as H4C, but that's really CH4, which we mentioned in the first option there is nonpolar. So we cannot have a hydrogen bond between that and HF. It's just not going to happen because this one is nonpolar. So it's not a polar molecule. And then finally, we just have hydrogen bonded to hydrogen. There's no hydrogen bond there at all. That is just a covalent bond. Even though it's between two hydrogens, it's a covalent bond. True hydrogen bonds are intermolecular forces. So that one's not correct either. So it is the H3N to the HOH that shows the correct use of a hydrogen bond. All right, thank you so much for asking your question, and I hope this was helpful.